This is the presentation of the lab which I did in Multisim, which is simulating what we should have done in the lab with real components. But anyway, here's a divide by 8 counter. Okay, we have standard JK set up in the toggle mode, and we have our oscilloscope or 1 kilohertz square wave going into it. And this one's set up in asynchronous mode where we're going from Q to the clock. It's opposite as the notes that I showed because the other one was a positive edge trigger. This is a negative edge trigger, so we're going to go from Q to the clock instead of the other way around. Here's the waveform of the divide by 8 counter. We're going to ignore this waveform because that's the clock. And we're going to start here. This is a negative edge trigger, so it's zeroed out here. So we have 0, 0, 0, 1, 0, 0, which is 1, 0, 1, 0, which is 2, 1, 1, 0, which is 3, 0, 0, 1, which is 4, 1, 0, 1, which is 5, 0, 1, 1, which is 6, 1, 1, 1, which is 7, which we reset. Okay, so we count from 0 to 7. There's our divide by 8. Here's a divide by 5 counter. We start with our divide by 8 asynchronous counters, and we're using a NAND gate in order to decode this. Okay, so when we do 5, what's 5? 1, 0, 1. So we're going to connect from Q's into our NAND gate. We're going to ignore this guy because he's a 0, so he's going to be there before the 1, so it's okay to ignore him. So 1, 0, 1, decode and reset. Here's our divide by 5 counter waveform. Again, we're going to ignore the clock. You see the end glitch, which is going to be take it as our start, and our end glitch right here. And we're going to again ignore the clock, and we have 0, 0, 0, which is 0, 1, 0, 0, which is 1, 0, 1, 0, which is 2, 1, 1, 0, which is 3, 0, 0, 1, which is 4. Our count 0 to 4, divide by 5. Here is our divide by 10. We have taken our divide by 5 decoder and our counter divide by 5, and we put a divide by 2 up front. So we have a 2 times 5, which becomes a 0 to 9 divide by 10 counter with an oscilloscope. Here's our divide by 10 waveform. Okay, you can see our glitch right here and here, which is our reset glitch, which we're going to use here as a start glitch. We're going to count this first waveform because it is now Q0, and so we're going to use that one. So we got 0, 0, 0, 0, which is 0, 1, 0, 0, 0, which is 1, 0, 1, 0s, which is 2, 1, 1, 0, 0, which is 3, 0, 0, 1, which is 4, 1, 0, 1, which is 5, 0, 1, 1, which is 6, 1, 1, 1, which is 7, 0, 0, 0, 1, which is 8, and then we have 1, 0, 0, 1, which is 9. So we have a 0 to 9 count, divide by 10 counter. Here's our divide by 10 again, and we've added probes, which will light up when it goes on coming out of our Q, so they're going to be the positive signal. And we'll animate this here in a second, but here's the layout. Here's the layout of the divide by 10 with LEDs coming off the Q0 in the syncing mode. What we should have been using in the lab. We'll go ahead and take a look at the other one here in a second. Here is our divide by 10 with our outputs, and I'll go through the count here in a second once we get back to 0. Okay, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then done.